Girls' brains throughout development seem to be reaching maturity 1 to 2+ years ahead of the boys' brains. And we know this, I've just mentioned this process of myelination, of connectivity. Well, the girls appear to myelinate, to cause the closure of this adult process 2 or 3 years earlier than boys. And when you look at brain growth, what happens across development is your brain grows and then it actually starts to prune itself a little bit as you become adult-like. So the number of brain cells in your brain is actually comes down a little bit to become adult-like. You want that. You don't want, it's a part of a pruning that's important. So when we look at when that happens, it happens a little bit earlier in girls than it does in boys. So actually, boys are completing the process into their late teens and early 20s, whereas girls are completing this process of connectivity and sort of the pruning part of the brain more towards the end of the teenage years, middle to end of the teenage years. Now, given that lag, it makes some people have suggested that we might consider some gender-based learning. Now, it is possible that the girls are ready to learn certain things possibly earlier than boys because of this ability that they mature sooner. And so one asks whether some subjects could be taught to girls earlier than boys, and we might need to consider this in terms of high school curriculum. However, ideally, this is not just gender-based. Every individual is going on their own little curve. And it would be, obviously, everybody's different. Even two boys are different from each other with respect to actually when they're reaching the end of their brain growth. And ideally, of course, in an ideal world, teaching to an individual's brain development would be the best possible, strategy. The interesting thing is that the teenage brain, because of it's still rather hyperexcitable compared to later in life, because it's still got some childlike qualities. And this brings with it some vulnerabilities to injury from a number of different things. One, of course, is substance abuse. Now, substance abuse and addiction actually turn out to use somewhat the same systems as normal learning does. So when you learn a task, you're memorizing, and we understand the biology of how brain connections actually strengthen with learning. Now, teenagers probably, as do children even better, do this learning very robustly. Unfortunately, addiction is kind of a form of learning, as you can imagine. The more you're exposed to something, the more affinity you have for it. And recent studies, only in the last 5 years, have shown that addiction actually does use some of the same molecular biology and physiology as learning. Therefore, studies have shown, both clinical and basic research, that actually teen brains can get addicted faster and stronger than adult brains. So teenagers can have a lifelong problem with trying to shed an addiction that has been acquired as a teenager compared to later. Addiction at any time in life is not good, but this is, it suggests that they are actually more vulnerable to this long-term process. In addition to the addiction issue, the drugs themselves can have more long-term effects on teenagers than even adults. So, for instance, alcohol would be a good example. Alcohol toxicity can actually cause more brain damage in a teenager than it can an adult. It's not good at any age, but the teenage brain can actually suffer more damage for an episode of, alcohol intoxication, of severe alcohol intoxication, for instance, than an adult brain. Another substance that's used is, of course, marijuana, and the cannabinoids, which is the chemical term for that, have been shown to affect teenage brains actually to a greater extent than adult brains. This is in animal studies, and there are some clinical trials that might be looking at this as well. And what has been found that there's actually a more longer-term impairment of memory, even up to a week out following one exposure to marijuana or a cannabinoid substance in experimental studies. So the effects are actually more long-lasting. There's another study where nicotine was exposed to either adult rats versus teen rats, you know, the equivalent of a teenage rat. And they looked at brain activity with an exposure to nicotine. And we know nicotine is a really addicting substance. Well, in the adult brain activated on exposure to nicotine, but the teenage brain was like 10 times more bright with this marker of activation than the adult brain. So it was really, really responding to this addicting substance. So again, it suggests that there is this possible explanation that because addiction is a form of learning and they do that better, that we have to take these issues more seriously. When we talk to these kids in the high schools, we're trying to give them that information so they can make their own judgments and learn that maybe it's not okay for themselves to do this kind of activity or subject themselves to these risks. But paradoxically, the risk-taking behavior, the judgment, the insight is the one thing that this group is relatively weak at until they grow into that ability. So we're hoping, since it's a fact-based generation, that by giving them facts, they actually might hear the facts, even though they may not necessarily be able to make that judgment call subjectively on their own.